We will start in a while. Okay, so we will start. We will start with new topic. Friction. So as you all are aware about the definition of friction, which you have been learning since your schooling level itself. So if I want to define friction, what it should be? It is defined as a resisting force, you can say, opposing force, which opposes the relative motion of any rigid body. Okay, so it is an opposing force which or resisting force which opposes the relative motion of a body. So if we talk in terms of a rigid body, let's say this is a rigid body which is placed on some surface. Okay, and this surface is necessarily a rough surface. Rough. It is a rough surface. Just take example of Earth. Surface of Earth, you will never find it to be smooth. It is always rough. And by the nature of the roughness, Earth being a rough surface, what will happen if we try to push this or pull this rigid body in one particular direction? Then you will find that this rigid body, if it is having certain weight associated to it, and if that weight is more than your body weight or pulling force, if it is more than that, then you will observe that by the virtue of the contact between this rigid body and the earth surface, which is rough, the resistance offered by the roughness will even increase the force which is exerted on this complete body. Okay? And if I say some amount of pull or push is provided to this rigid body, then the amount of resistance which will be offered by this earth or rough surface, it will be in the opposite direction. Okay, so this is known as the resisting force, or it is also known as friction force, frictional force. In addition to this friction force, we will have this normal reaction which is developed because of the contact between this rigid body and the earth surface. So we are interested in knowing about this frictional resistance, and as per the definition, it is the resisting force which will oppose the direction of the relative motion of the bodies. Okay. So with this example itself, let us try to explore more related to rigid body mechanics. So let's say this is a rigid body. It is having some weight associated to it. It is placed on some rough surface. It is given certain amount of pull in such a way that the motion will not start. Motion of this body in the direction in which the force is applied, it is not started. It is yet to start. So experimentally, it has been observed that a certain relation is developed between the friction force and the applied force. And if we try to plot this thing, if we try to plot the relationship between the frictional resistance or frictional force versus the applied force, it is observed that some amount, if we start with zero force, then with increasing this amount of force P, that is your applied force, from 0 to some finite value in such a way that there won't be any movement. But because of this application of force, the frictional resistance also increases. That is, with the increase in the application of force, frictional resistance, it increases somewhat linearly as shown in the figure, and the angle which is observed is 45 degree. Okay? This is an experimental evidence which I am talking about. It will increase with the increase in the p value to a certain limit, after which, with the further increase in the pressure or applied force, there is a sudden decrement in the frictional resistance, right? And after this, with the further increase in the frictional, with the further increase in the applied force, this frictional resistance, it remains same like this. Okay? So this is a typical plot between friction and the applied force. And what we are supposed to take from this figure is whatever linear variation we have observed over here between the applied force and the frictional resistance, this up to this point where the frictional resistance is maximum, this is known as maximum available friction. Maximum available friction. And up to this point, you will observe that there is no movement in this rigid body. There is no movement in the rigid body. Whereas after this, that is after this point, if we increase the amount of applied force, you will observe frictional resistance reduces, and because of the reduction of the frictional resistance, now the rigid body tends to move. That means it will lose its equilibrium state and it will try to get into dynamics. It will try to move. It will try to get displaced from its original position. Okay? So up to this point, which is known as maximum available friction, up to this point you can say the rigid body is still in equilibrium. It is steady. However, after this, you will expect that the rigid body will gain its motion and it will try to move. So you can call this friction, which is linear friction, to be static friction. Whereas this friction, you can term it as kinetic friction. Okay? Is this clear? So we are actually interested in this static friction. Why? Because you can see the variation is quite linear. Also the angle is of 45 degree. So being linear variation, we are in a position to make use of several equations or formulations. And therefore, this static term is very important for us. A static friction term is very important for us. Right? So have you understood this thing? Static friction. Okay, so this is friction capital F, which is denoted by capital F, and this is applied force capital P. So is this okay? Okay. So next, frictional resistance actually depends on the amount of the wedging action, you can say, of the contact surfaces. So the measure of this wedging action, whatever wedging action takes place between the rigid body and the other surface to which on which it is resting, or for which it is contacting. That wedging action depends on the normal pressure or the normal reaction between the surface. Okay, and based on this, that is this normal reaction I am talking about. Okay, and between these two, we have got one relation associated to it, which is known as maximum friction. As you can see from here, what you term this as maximum available friction, I will call it as F max. Okay, so F max is directly proportional to normal reaction. This equation we can derive for this condition. F max is actually in direct proportion to the normal reaction. Why? As a result, the maximum frictional resistance that may exist is proportional to the normal pressure, and it is expressed in this manner. Or it is also expressed in this term. F max is equal to mu s times n. I will let you know what is this mu s. Okay. So what is this mu s? Mu s is known as the coefficient of friction. Coefficient of, here it is static friction. Static friction. Otherwise, mu is known as coefficient of friction. Okay? So depending on this variation, you can observe there is a relationship between the F max value and the normal reaction value, and it is given in terms of direct relationship. F max is equal to mu times n, right? Mu s is nothing but the coefficient of static friction. Static friction in the sense we are only dealing with this part. We are not interested right now. We are not interested in this kinetic friction. Okay, because this is not you can say a linear type of thing. This is a linear thing, and we also know experimentally it has been found out that the angle of this linear variation is 45 degrees. So is this okay? Okay. You people are knowing all these things. Just this is a revision for that. Now in this same figure, if I want to represent the relationship, you know, F max, I will call this as F max. Why I am calling this to be F max? Because this force P, whatever is available over here, this is causing this rigid body to be in equilibrium. Try to understand. This body is still in equilibrium, but after small increment or further increment of P value, this rigid body will move. That means this condition is known as just impending motion condition, right? When this condition arrives, in that case only this frictional resistance will become maximum. Just remember that plot. This, right? This is the value for F max. What is happening over here at this value? The force which we are applying, it is of that order that beyond which the motion of the rigid body will start, or the impending motion will start. Okay, so F max is arrived at this point. Okay, so now let us try to explore a relationship, whatever we have developed between F max and N, in terms of its resultant value, because you can see these are the components. You can say this is the X component and this is the Y component of certain force. Can I say that this is that force, resultant force, which is acting in this manner, isn't it? So I will call it as resultant force R, and this resultant force R will have a relationship between the horizontal, not this angle, this angle, let's say. Okay, this angle is denoted by phi, and this angle phi is known as angle of friction. Phi is known as angle of friction. Are you getting me? Okay, this is known as angle of friction, and if I want to express this value for angle of friction, so it will be nothing but tan phi. Tan phi will be equal to, can I say, F max divided by N? Will it be okay? F max divided by N. Yes. Yes. Am I audible? So is the relationship okay? Tan phi is equal to F max by N. If I am assuming this angle, and this angle actually is known as angle of friction, and this angle of friction will be of our use whenever we will be solving certain numerical related to friction force. So is this okay, this relationship? Fine. So it is nothing but this case. Like this, and we are actually finding out, I mean, this is normal reaction, this is F max value, and this is that resultant force, and we are actually finding out this phi value. Okay. Now this phi value, actually angle of friction, it is actually denoted by phi s, and we are only talking in terms of static case, and therefore you will see all the terms shall be phi s. F max is only related to the static force itself. Okay, so this is angle of static friction, and mu s will be angle of coefficient of static friction. Phi s angle of static friction. Okay, so these two terms are very useful for the people in order to solve various numerical. So is this okay? Then associated to this, there are laws of friction. They are also known as Coulomb's law of dry friction. You must all be knowing about this, or is it required for me to tell you the different laws which are associated to Coulomb's law of dry friction? Do I need to tell you, people? Or you can take up this as an assignment, and you please identify what are the Coulomb's law of dry friction. Okay? ठीक. So with this understanding, let us take a few numerical examples. And our understanding should be very much restricted to the static force itself, or we still are not going into that dynamic part. We are still restricting or uh, restraining ourselves to this static portion only. That means the rigid body, whatever we are assuming, that will be in equilibrium. Although external force will be applied to it in the horizontal direction or the direction in which the two bodies are in contact with each other, that force will try to move that body. But what we are doing, we are not expecting that body to move further. It will just start its impending motion, or it will just start to move. It is not actually moving, it will just begin to move. That means this F max value is achieved. So we will be concentrating only up to this value, and whatever equations related to this, those I have discussed. That is, F max is directly proportional to n, or in other words, F max is equal to mu s time n. तो इसको हम n ना कहते हुए n r कहेंगे, normal reaction, in order to avoid confusion between the unit. So therefore, let this be nr, normal reaction. Okay, and another term shall be phi s. Tan phi s will be F max divided by nr. So we shall be restricting only up to this, and we will see various numerical examples. Okay, so you can write down first numerical. A 400 Newton block is resting on rough horizontal surface. 400 Newton block is resting on rough horizontal surface for which the coefficient of friction is 0.4. 0.4. Determine the force capital P. Determine the force capital P required to cause motion. Required to cause motion to start, to just start. Required to cause motion to just start if the applied force to the block, if the applied force to the block is first horizontal. First case is if it is horizontal. Second case is downward at 30 degree with the horizontal, if the force is acting in the downward direction at an angle of 30 degree with respect to the horizontal. And third case is what minimum force is required to start the motion. What is given? This is a rigid body like this. It is resting on rough surface. The weight of this body is 400 Newton. Okay, this is the rough surface on which it is resting. Coefficient of friction is actually given. Coefficient of friction, and necessarily this is coefficient of static friction. If you read the example, that's why that the wordings are very, very important. What it says, just I'm repeating the question. Determine the force required to cause the motion to just begin or just start. इसका मतलब है whatever coefficient of friction given in the numerical is, it is related to the static friction. If it is static friction, what does that mean? Whatever friction we are finding out, that is maximum frictional resistance, F max. Okay. As per the definition of F max, what it is? Mu s times nr, isn't it? Out of this, we know mu s value. This is given in the numerical itself. We need to now find out F max depending on this nr value. So what is this nr? We will draw the free body diagram associated to this. And yes, the force P in the given numerical, it is acting in this manner. This is x direction. This is force P. So we need to identify this P value with this given information. So the free body diagram associated to this shall be nr. Okay. Now let me know. I would like to hear from you people. If the direction of the force which is applied on this rigid body in this way, what should be the direction of frictional resistance?
Opposite.
Opposite in the sense?
Left side.
Okay. Like this. Okay. I will be representing the frictional resistance to be half arrow like this. Okay. So this is F max. Correct? Equal to mu s is actually given 0.4 into normal reaction. Right? Now, since it is F max value and everything revolves around the static condition or equilibrium condition, we can directly make use of equations of equilibrium. Okay? And that is the beauty of this F max value. We are in a position to make use of equations of equilibrium directly. So, summation of forces in x direction. How many forces do you observe? P, which is in the positive x direction, minus F max equal to 0. So you can elaborate this. 0.4 times nr equal to 0. Can we find out this nr value? Yes, definitely. It is very simple. Summation of force in y direction equal to 0. How many forces do we observe? Take a minus 400 and another one is nr. As simple as that. And therefore, normal reaction comes out to be 400 Newton. Substitute this value in this equation and get P value. It comes out to be 160 Newton. Barabar hai?
Yes, sir.
So this P value, whatever we have calculated, this value shall be responsible for the just beginning of the motion of this rigid body. This is what is the conclusion. This is case 1. Case 2. What is case 2? In case 2, instead of this horizontal force on the same rigid body, one force which is acting in the inclined direction, downward inclined to the right, like this. This force is applied. Let me call it as again capital P. Rest this weight for 400 Newton. This is same. This is again rough surface. This is normal reaction. All the other conditions are same. Now tell me, in which direction do you expect this rigid body to move? First of all, कौन से direction में move हो सकता है? Yes. Can anyone tell? Because of this, and the angle which is given is 30 degree
The right direction.
in the right direction. Okay. So what makes you feel that this rigid body shall move in the right direction? Yes. For that, let us try to understand the resolution of forces. Okay. This force P being inclined at an angle of 30 degree with the horizontal, you will find that this P cos 30, this value will be there acting in the positive x direction, right? And another force, another component will be acting in the vertical direction. So this component shall compel this rigid body to move in the right direction. Okay. So this is the representation, and this is nothing but the complete free body diagram like this. This is an arc, and since it is moving in the right direction, what will be the the frictional resistance in the opposite direction? What shall be the magnitude? F max. Okay, and this coefficient of static friction is actually given as 0.4 times an hour. Okay, this will become E sine 30 degrees. Again, same equations of equilibrium can be easily applied. So forces in x direction equal to 0. What do you find? P cos 30 minus 0.4 times an r equal to 0. दो unknown है. One unknown can be found out by using summation of force in y direction equal to 0. So nr positive minus p sine 30 minus 400 equal to 0. ठीक है? Equation 1, equation 2. You can solve these two equations, and based on that you can calculate the nr value as well as p value. Can you do that? Please do it fast. Please let me know the values. By that time I will draw the sketch for the third case. You please evaluate this. Yes, anyone? Yes, what are the values for nr and p? Please let me know. Anyone? Are you people there? I am getting p value to be 240 point how much 23. You please verify.
Sir, NR 521.21.
NR 521.21. Okay. NR equation comes out to be 2.165 times this value. P कितना आ रहा है आपका? How much value for P you are getting? 2.165.
Sir, 240.73.
Acha. NR I am getting to be 520.09. You can verify this. Okay. Now, let us concentrate on case number 3. What it says that you are supposed to identify the minimum force, minimum value of force. So whenever such minimum values are asked, what you are supposed to do? You are supposed to consider first of all in the absence of given information. Now see, in third case, I don't know what is the exact position of that force, whether it is vertical or horizontal. I don't know. So in that case, I need to consider it in some inclined fashion, first of all. Secondly, when it is said that minimum value of the force is required, in that case, inclined force is to be considered, and with the help of that inclined force, whatever associated angle it will have, with respect to that angle, we need to find out its partial differentiation. For example, let me consider this p value and the inclination of this p value in this manner, and it is making an angle of alpha with respect to the horizontal direction. So in order to calculate the minimum value of force, I can make use of this equation, right? For minimum P, I can use this equation, right? So initially I will be assuming the direction of force to be in this manner. I don't know whether it is correct. It will be found out after the final calculations. Okay. So let me assume the direction of this P to be like this. NR will be like this. And since one of its component will be in this direction, cos component, and therefore this will try to move in the right direction. And hence, the frictional resistance shall be in the opposite direction. Let me consider this to be F max. Over here it is given as 0.4 times NR. Mu s value is actually given as 0.4. So this will be the free body diagram associated to case number 3. Now it's a matter of calculation. So what you do, you resolve this into components. This will become P cos alpha. This will be P sin alpha. Okay. Make use of equations of equilibrium. P cos alpha positive minus 0.4 times NR equal to 0. Then summation of force in y direction equal to 0. NR positive minus 400 negative direction. Over here it is plus P sin alpha, okay, equal to 0. You express everything, these two equations, 1 and 2, in the form of P. So I am getting this P value after solving it to be 400 divided by 2.5 cos alpha. 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 cos alpha plus sin alpha. This is what I am getting. You can verify. After eliminating an R value, I am getting P value in terms of this to be, that is cos alpha and sin alpha to be like this. And then I can definitely make use of this equation to find, since P is minimum. So in order to find out minimum value of P, dP by d alpha will be equal to 0. You can calculate this value. From this, I am getting alpha value to be 21.8. 21.80 degree. You can check it. And after calculating this alpha, you can calculate the P value. P I am getting it to be 148.5. ठीक है? Is this okay? You can do the calculations, right, and try to identify the alpha and P values. Right. Next example. Here, what is given? There is a block of 500 Newton, and that block is resting on an inclined surface. That inclination is given as 45 degree. Coefficient of static friction is given as 0.25. You are supposed to compute the values of horizontal force necessary to, first case is just start the block up the incline. So first case is you are supposed to find out the value of force which will cause that block to just move in the upward direction of the inclined surface. Second case is just prevent the motion down the incline. That means you are supposed to find out the value of P, the force which is applied in such a way that the rigid block, it should not move down. And third case, if the value of the force is 400 Newton, what is the amount and direction of the friction force, right? Third case is typical. First two cases are simple. So first case is, this is the rigid body, this is the inclined surface. It is not smooth since coefficient of friction is given. Mu s is given as 0.25. Okay? And this is the horizontal force. Okay, first case is you are supposed to identify the horizontal force which will allow the motion in the upward direction. It will not allow it to move, but it will just start the motion in the upward direction. If this is the case, then can you please tell me in which direction should be the frictional resistance? Yes, in the downward direction. Okay. So let me consider these to be the axis of the rigid body, X and Y. You are free to consider the axis. So therefore, based on the condition, the frictional resistance shall be in the downward direction. F max equal to 0.25 times NR. So where will be NR? NR will be perpendicular to the a rigid body like this. Do you agree?
Yes, sir.
Let me consider this force to be capital P. This is unknown force. Now, based on this, you can definitely solve this numerical. How you will proceed? This is inclined. See, you can consider this to be fixed. ये इसको आप true x और true y consider करो और इसको आप inclined consider कर सकते हो. So in that case, this will be the situation. Do you agree? Okay. And what will be this angle? What will be this angle? ये angle और ये angle same रहेगा. Don't you feel? Because what we are saying, we are considering this to be x-axis, right? So this will be 45 degree. Do you agree? So accordingly, this will be P cos 45. Then what you do? Summation of forces in x direction equal to 0. P cos 45 minus 0.25 NR. Okay? Because these are now the x and y axis respectively, equated to 0. Second is summation of forces in y direction equal to 0. NR minus P sine 45 minus, okay, now the self weight is also acting like this. What is the self weight given? It is 500 Newton. 500 Newton. So what you can do, you can resolve this again. Okay. And what do you observe? This will be the y component, this will be x component. So now what has happened? In case of equation number 1, you will have one more term which is of minus 500 cos of 45. Do you agree? Because this angle, based on the geometry, this will be again 45 degree, okay, equated to 0. This second equation shall be now NR positive minus this value P sine 45 and minus 500 sine 45 equal to 0. Correct? This is equation 1, equation 2. You solve these two equations. Okay? Eliminate first of all NR. So what you do? You multiply equation 2 by 0.25 and then you add these two equations. You will get the value for P. Okay? So I am getting value of P to be 833.2 Newton. And similarly, NR I am getting it to be 942.8 Newton. You can verify this. Okay? Second case, what is the second case? In second case, same rigid body is given. Same thing is given. Angle of inclination is same. But the only difference is that you are supposed to identify that horizontal value of P, which will hold the motion of this rigid body in the downward direction. That means in this case, what is given? That the body will try to move in the downward direction, or it is in motion, just moving in the downward direction. So what will be the direction of frictional resistance in this case? Yes. What will be the direction of frictional resistance in case number 2? Are you people there? Yes, please let me know.
Sir, upward.
It will be upwards. Okay, like this. Okay. And this will be the normal reaction NR. This is frictional resistance 0.25 times NR. And this will be P. So you resolve this into components like this. Even you are supposed to resolve this 500 Newton value into two components. This angle, since it is 45 degree, therefore this angle is again 45 degree and this angle is again 45 degree. So the only change in case number 1 and case number 2 is the direction of F max. That's it. So you can formulate the equations and you can solve the value for P and NR for case number 2. Third case I will be discussing in the next class. Okay, this is a typical example wherein you will find there is the motion is not known actually. So first of all, we need to decide in which direction the rigid body will move, whether it will be moving in the upward direction or by the virtue of whatever load and whatever force available over here, whether it will try to move in the downward direction. That we first of all we need to verify, and after verification then we will be in a position to identify the actual value of P, which will try to keep that rigid body in steady state or equilibrium. Okay, so that case number 3 I will be discussing in the next class. But before that, you please try to solve this case also and try to identify the values for P and NR. Okay, so I will stop over here. We will meet in the next class. Thank you.
Thank you, sir. Thank you, sir. Thank you, sir. Thank you, sir.